Hello, I'm Greg, and this is the 7th episode in my series on how to recreate Defender in Unity. So if you've ever wanted to learn how to make a game from scratch, especially a classic arcade game like Defender, then grab your favorite beverage and pull up a chair and follow along as I show you how to recreate Defender in Unity. Okay, so in our previous video, we got smart bombs working, and we got hyperspace working, and we fixed the issue where the player ship was killing itself with his own shots. I thought in this episode we'd add some more unit tests to cover that new functionality, but before I do that, I wanted to fix an issue I noticed when I was editing the video for the previous episode. That in our player ship script, when we subscribed to the events, and I always copy the event to unsubscribe, but I noticed that I forgot to change this to a minus here. So we're not actually unsubscribing, we're actually resubscribing again, so we're subscribed twice. So I want to just fix that real quick. When you're doing copy and paste, it's really easy to overlook something like that and make a dumb mistake. And there you can see I did it. When I copied and pasted that, I forgot to change it. Okay, and so now that I've fixed that, let's jump back into Unity. And I want to add some unit tests to cover the new functionality that we've added. So if we go over to our test runner, and here under mob test, I think this would be a good place to add some more mob tests. So I'm just going to select this and I'm going to right click and say open source code. And that opens our source code up here. And I'm going to want to add a few tests in here actually. Right now we've only got the one where we test to see if the human should scroll when the player thrusts. I want to be able to test smart bombs. I think the first smart bomb test is just going to be to make sure that all the enemies in range should be destroyed by a smart bomb. And so actually, in order to do that, I think I need to add some enemies to our test scene. So let's go back into Unity, and we'll go down to Scenes, Test Scenes, and we want our mob test scene. And right now we've only got this human. There's some other things we should probably clean up while we're in here. We really do not need... we don't need all this UI stuff in our test scene, so I think I'm going to delete that. I'm going to create a new empty game object here, and I'm going to call this mobs with the dashes just to distinguish it from other things. And then I'm going to drag our human under there, and we're going to create a few more. We're going to go to our prefabs, our mobs, and we're going to drag a lander in here. And he's right here. Now he's got that blip. And I'm going to go over to our camera and change his culling mask to not show the overview map. Not that it really matters. I just want to be able to see clearly that's a lander. And let's duplicate our lander. And we're going to move him up a little bit just to distinguish him from there. And now let's duplicate him again. And we're going to move this lander... Oops, I picked the wrong one. I thought I duplicated that. Control D, okay. So now I'm going to take him and drag him out of view. So now when a new player ship spawns on the screen, only these landers should be within bomb range. So now we can go and write our test. If we go back to our test runner and we right click here and say open source code, let's start writing a new test. So Unity test. Remember, it's got to be a coroutine, so public I enumerator. And I'm going to call this enemies in range should be destroyed by smart bomb. Nice descriptive name, all lowercase with hyphens. This really helps distinguish it from other functions in our game. These are clearly unit tests. Let's do our arrange act assert pattern. I don't always do this, but if it's a case where it can be really clear, I'm going to do it. So first of all, I want to get how many current enemies we have. And I'm just basically going to say object dot find object of type. And we're going to say smart bomb target, because remember, all of our enemies that can be destroyed by a smart bomb will have that smart bomb target on it. And I actually want to get the length of that. So I'm essentially, I want to say get objects of type. I'm going to get a collection of those, and then I want to get the length of that collection. That will tell us how many enemies we have. And just to make sure that everything is kosher, we're going to say assert r equal 3 enemies. So you remember we added 3 landers, so there should be 3. Let me just run that and make sure that that passes. We have an error. Oh, we need to have a return. So we will say yield return null just to pacify this code here. And that's because we are returning IEnumerator. So let Unity recompile. We should see our test appear up here, and there it is. And let's say run selected. And it passed. Good. All right, so what do we want to do next? Now we want to act. So the way we're going to act is we're going to tell the user input to basically fire the on smart bomb pressed event. We're going to say we're firing it by saying raise event of type action. And that will fire the event once. Now we need to add our using statement for the system reference so that we can get this action, and what that added was this using space right here, because action is in system. All right, so we're going to fire that event, and then we want to yield 1 frame. So we will say yield return null. Then we want to do our assertion. We want to assert that there are only 1 enemy left. So actually we're going to have to take this code and copy it and just change the assertion to be 1. So remember, there should be 2 enemies within smart bomb range. They should both be destroyed, which should leave us with 1 enemy. And I'm going to give a little message here and say only 1 enemy should remain after smart bomb used. And I'm going to put a little message up here to say we should start with 3 enemies. All right, let's go back out into Unity, and we'll give that test a test run. And run selected. Oop, you see our explosion begin there, and it has passed. So there's 1 successful unit test. Okay, and if I play the game, I'm not sure this will work. We don't have any UI. I was going to say, we know that when we use our smart bombs, that it decrements the number of smart bombs that we have. And so I want to add a unit test for that condition. So we'll come back in here, we'll add another test. Unity test. And we'll call this one smart bombs should decrement when used. And we are going to assert that we initially have 3 smart bombs. So you remember in our test setup, we are getting our game manager from our test helpers class, and by default it should start out with 3 smart bombs. So let's just make sure that that is working. Oops, I want to do yield return null. That's just to pacify the IEnumerator return type so we don't get an error. Go back into Unity, give that a test and make sure that that runs and passes. And it does. Okay, so the next thing we want to do is act. So this is our arrange. Let's act. And all we're going to do is say user input. Actually, we can copy this and paste it. So all we're going to do is fire off that smart bomb pressed event. And now we want to assert that we now only have 2 smart bombs. And I think that should be all we need for this. Let's jump back out into Unity and give that a run. And it failed. Oh, what did I do? I passed something wrong in there. It said it was expecting 2. That's probably just a simple typo on my part. Oh yeah, duh. I need to put dot smart bombs. Yeah, even a seasoned, experienced developer like me makes stupid mistakes like that occasionally. Some YouTubers might edit that out, but I think it's good for you to see how the sausage is made. And that passed. So I think the last smart bomb test that I want to write is basically to make sure that the smart bomb event should not fire if we are out of smart bombs. So this would be a little bit more involved. Not a lot, but a little bit. So again, once again, public IEnumerator. And this will be called, just like I said, smart bomb event should not fire if no more smart bombs. I think in my mind I was thinking if out of smart bombs, and I was saying if no more smart bombs. Okay, so let's just do a yield return null to pacify the compiler. I need to spell yield correctly. All right, so what are we going to do in here? The first thing, again, is we're going to assert that we have 3 smart bombs to start with. All right, now we want to act. And I'm going to do this in a loop, but I think I want to make sure that we don't get stuck in an infinite loop. So I'm going to add an exit condition that's different from what we're actually testing for. This will make sense when I do it. I'm going to say var iterations equals 0. I want to make sure that we don't get stuck in an infinite loop. So I'm going to say while game manager.smartbombs is greater than 0. So I'm assuming that every time we fire a smart bomb, we're going to decrement the smart bombs. And just to prevent an infinite loop, iterations, and I'll go ahead and increment it, is less than 10. So essentially, I only want to do this until smart bombs is equal to 0, or we've tried this 10 times. And all we're going to do in here is we're going to fire our smart bomb event, which should decrement. Now, I want to change this. I don't want to do a yield return null. I actually want to do a wait for seconds because you remember we have a delay. We have a delay of 1/4 of a second between, so we can't spam the smart bomb button. So I'm going to actually delay for 0.3 seconds. That should give us plenty of time to process this event before we try it again. All right, so this should theoretically fire the on smart bomb pressed event until we are out of smart bombs. So then I actually want to test that if we fire the smart bomb event again, we don't want to, well, if we press smart bomb pressed again, we want to make sure we don't fire the event on the game manager that says smart bombs changed. So the way that we are subscribing, or handling the smart bomb press as we are subscribing to an event on the game manager on smart bomb changed. So first of all, let's make sure we're really out of smart bombs. Let's say assert. I have caps lock on. What's going on here? Assert R equal 0 game manager smart bombs. And that should definitely be the case because we decremented them until we were gone. But it might be false if we broke out of the loop because we had 10 iterations and this didn't work for some reason. So we want to test that. And I'm going to put a little message. We should be out of smart bombs. Okay. Now, here's where we're going to set up for the last part of our test. We want to say that the game manager's smart bomb changed event, we want to subscribe to that event. We're just going to handle it in here. We're going to take the bombs parameter, which we're not going to use for anything. And we're going to use a little lambda expression to do an assertion. We're going to just say assert fail. And we're going to give it a message and say smart bomb event called when no more smart bombs. Right? And then just give a terminating semicolon there. So basically we're subscribing to this event, and if it gets fired, we're going to fail the test with this message. Now we're going to go ahead and fire the event, just like we did up here. And finally, our assertion will be assert.pass. So if we get this far, the test passed. Because if it fails, it's going to fail in here. All right, I think we can run that and it should pass. And then I'm going to come out and force it to fail by changing this value here, because I want to make sure that if this doesn't work, the test will correctly fail for the right reasons. So let's go back out into Unity and run selected. And it should take a little bit longer to run because we're iterating through that loop until we're out of smart bombs. Okay, so it passed. Now let's go make it fail. All I'm going to do is we're only going to loop until we're down to 1 smart bomb. So we still have 1 smart bomb left. We're going to subscribe to this event. We're going to fire the on smart bomb pressed event, which should, if I'm right, will catch that event here and assert a failure, showing that that did not work. So let's go ahead and run selected again. And you see it failed, and our message is, oh, it failed, but not for the reason I was thinking. Let's go to the error line. I want to comment out this assertion here. But yeah, that's correct. So we know that this works. If we're not out of smart bombs at this point, we know that something didn't work in here, so that's good. But let's see if we can get the second failure condition to happen. It failed, and the reason is smart bomb event called when no more smart bombs. So yay, we know that the test works correctly and that if there is an error, if for some reason that doesn't work, the test will catch it. And we also know that it's working currently because the test as originally written passed. So I think that's good for smart bomb tests. The last test I want to do in this episode is testing our hyperspace. And so that's actually going to happen in the player movement test. Okay, so jumping back into Unity. This time we'll go down. Let's run this. Make sure that all these tests pass. That's really obnoxious, those sound effects. Okay, so all our tests are passing. Let's go into our player movement test, open source code. And I want to add a new test down at the bottom here. And I'm going to call this Hyperspace should teleport ship. So for our range, all we're going to do is save off our start position. using our player ship's transform position. And then we are going to act. And the way we're going to act is we're going to say user input dot instance dot on hyperspace pressed. We're going to raise that event. And of course we need to yield for 1 frame to let it process that event. And then our assertion will be basically that our position changed. We're going to take our start position and compare it to the player ship's current transform position. And we'll give it a message saying should have teleported. Jump back out into Unity. And we will run select it. And it passed. So I think it's time we start getting into some game state. So I want to create a simple state machine, but I want to go back to what we were doing a few episodes ago with test-driven development. Since we're doing some unit tests again in this episode, we'll start with unit test for the state machine, and we will develop the state machine to get the unit test to pass. So if you remember test-driven development, it uses a red-green refactor iterative pattern. So red being failing, green is passing, and then refactor is basically just a refactor of the code as needed to make it more efficient and cleaner and easier to read and maintain and better organized. So we'll first write unit tests that won't even compile. Then we'll get them to compile, but they'll fail because we haven't implemented all the code behind them yet. And then we'll get them to pass. And we're only writing just enough code to get the unit test to pass. And I want to use edit mode test this time. Now, when we created our unit test project, it created a couple of sample unit tests, which we really don't want. It put them in this scripts editors folder up here, edit mode test. I'm going to go ahead and delete that because we do not want that. So now we can create a new edit mode test assembly folder, and we'll put it in our own testing folder here that we've got, because right now we got our play mode test. Let's create a new one, and I'm going to call this edit mode test. And if we go in there after Unity finishes thinking about it, you see it created an assembly definition file for us. We don't want the test runner. That is for play mode test. So I'm going to go ahead and delete this and then change this to be Unity editor test runner, which is what we want. And then we need to add our defender scripts. And we're also going to want to add in substitute. And I'll go ahead and save that. And we can apply those changes. And we're going to want to start working on our actual unit test script file. So let me just shrink that down a little bit. And I'm going to right click in here and say create C# script. And I'm going to call this state machine tests. And I will double click this and we will zoom in, and we don't need it to be a mono behavior, and I don't believe we need this. It is going to put in the unit test or the in unit and in substitute namespaces. So we're going to start off by just creating a test method. So this is a little bit different from the play mode test. Let's go ahead and import the missing references. So there's our in-unit framework. Edit mode tests are really good for testing things that are not mono behaviors. And I'm doing this because I want to show you that not everything in Unity needs to be a mono behavior. And there's some things that's just raw logic, raw game logic, that is actually better if you keep it outside of a mono behavior. And you're going to see how much faster these tests run too. So really, ideally, when you're writing unit tests for a game in Unity, you want to do as much as you can edit mode tests as opposed to the play mode tests that we've been doing. So I'm going to create a function here. And I'm going to call this, oh, by the way, I have to say this. I just want to go on the record to say that the pattern that I am using, the implementation for the state machine and for these unit tests, I'm pretty much taking directly from Jason Wyman's Ultimate Game Dev Master Architects course. I've done a lot of different types of implementations of state machines, and there's really no wrong or right way to do it, but I really like this implementation, and I think it'll work well in our game. So I want to give Jason Wyman credit. I'm borrowing very heavily, almost copying directly from his implementation. So this function I'm going to call initial set state switches to second state. Or actually just switches to state. So initially, this isn't even going to compile. We'll get it compiling, and then it won't pass, but then we'll get it passing. So I'm going to say, we're going to instantiate a variable here. We're going to call it state machine, and it's going to be a new state machine. Now, state machine doesn't exist, so of course this is not going to compile. It's actually complaining and thinking I'm trying to use an obsolete state machine from in Unity Editor internal, which we don't want. So we'll delete that using statement so it knows this is an undefined type. And then we're going to declare a state. We'll call this first state. And we're going to use in substitute. So we're going to create a substitute for, and this is going to be an interface called iState, which also does not yet exist. And then we're going to set the state on our state machine to first state. And of course, this doesn't exist yet because this doesn't exist yet. And finally, our assertion is going to be our same, not our equal, but our same first state in the state machine's current state. So there's a lot of things that don't exist, and none of this is going to build until we create them. So let's go back out into Unity, which of course is going to complain mightily about all these errors that we've introduced. Under scripts, we're going to create a new folder, and I'm going to call this state machine. And we're going to go in here and create our interface first. So create C# script iState. And we're going to go in here and zoom in. This is not going to be a mono behavior, and it's not going to be a class. It's going to be an interface. We don't need Unity Engine. Okay, so now let's go back over here, and you can see that it's happy about this. We still don't have a state machine, so let's go back into Unity. And we will right-click here, create C# script state machine. Now this is going to be our state machine base class, and we're actually going to have multiple state machines in our game. But this is going to be the main machine, if you will, that will manage transitions from one state to another for different types of states. And that'll all make sense when we actually start using it. But the first thing we need to do is create this class, which we have here now. And if we go back to our test, you can see this is happy, but we don't have a set state. So I'm going to hit Control+, create method, and that creates this, and we're just going to call this state. And going back into our test script, we want to add current state. So we'll hit Control plus, or I'm sorry, Control period. And I actually messed that up. So again, put my cursor on there, Control period, and we want to create a get only property called current state. And I'm going to move that to the top of the file. And we're going to call this iState. That is going to be an iState. And it's going to have a public getter and a private setter. And in set state, I'm going to say current state equals state. So let me go into our unit test. It might actually pass now with that code that we've added. Doesn't it know that's not a mono behavior? Oh, let me go into our state machine. Aha! I'm glad that Ryder gave me that warning. Our state machine is not a mono behavior. It is a pure C# class. Good catch, Ryder. All right, let's just run this test. I'm going to right-click and say Run Unit Test. And it already passed. So that was quick. So we kind of bypassed the red and the red-green refactor step and got it compiling and running at the same time. But it's still not quite right. We want to add some more tests. The next step is we want to try and change states. So we're going to say public void second set state switches to state. And I am going to copy some of this. But we're also going to instantiate a second state. Oop. And we are going to start out by setting our state to the first state. And we will again assert, I'm going to put a little message here. Expected first state. I'm just going to copy this. And then we're going to call set state and pass in second state. And we want to assert that they are the same. And again, I fully expect this to pass. Why isn't it giving me the run unit test? Here we go. I think we're going to have to go back out into Unity. Sometimes it doesn't build. Oh, do we have a compiler error? No, we don't. Okay. Let's just run all these from here. And they all pass. Good. Now, really our state machine isn't doing much right now. We're just setting the state to whatever we pass in. We're going to want to manage transitions from one state to another, and we want those transitions to be controlled by a condition. A condition has to be met in order to transition from one state to another. So let's create a test for that. And this will be transition switches state when condition is met. So let's go ahead and copy all of this. And we're going to add a transition. We're going to say, well, first of all, I want to have a condition function. Should transition state, and this is just going to be a lambda that returns true. And now our state machine we're going to add a function here called add transition. We want to transition from the first state to the second state if should transition state is true. Now I'm passing in the function, not the result of the function, and that's important. Okay, and so then we're going to do a tick on our state machine, which doesn't yet exist. And that will allow it to basically process a frame, if you will, inside the state machine. And then we're going to check to see. I actually want to do our assertion here. Just to make sure our start condition is correct. I want to add this method here, expected second state. All right, so we're starting off with our first state. We set this condition state to be true, transition state to be true. We're going to call add transition and add a transition from the first state to the second state if that condition is met. We're going to let that state machine process a tick. And then we're going to do an assertion to see if we are indeed on the second state. So assert our same second state, state machine dot current state, expected second state. All right, these don't exist, so we'll hit control period, create method, and I'm just going to delete that. Come back into here, control period, add that function. And I'm going to delete that. So now it should all compile, but if we run this, I don't expect this to pass. In fact, let me do a build here. So it didn't like the method signature that it created. Let me minimize that and minimize that. We're going to go into our function here. We want this to be from, to, and this is going to be a func of type bool. And we are going to want to import that type. And then this is going to be a condition. All right, go back into our unit test and try and build again. This should all build. By the way, I hit Control-Shift-B to build. All right, this is complaining about a cast somewhere. Oh, that's nothing. Don't worry about that. All right, let's run this unit test now. I expect it to fail, and it did. So I'm not sure why it didn't run. Sometimes it runs in the editor, sometimes it doesn't. I'm going to try and run it again just to see what happens. I'm going to try and run them all. Oh, it's running. Oh, I know what's wrong. I've got play mode test selected. Okay, yeah, so you can actually select which type of test you want to run when you run those tests in the editor. So let me try that again. Let me go back to here, select edit mode test, run all, and we got this failure here. And we're not running our play mode test, so that's fine. Okay, so let's take a look at our failure. We expected second state, so obviously it didn't actually do the transition. Why? Because we haven't implemented that yet. So let's jump into our code for our base class here, our state machine class, and let's implement this stuff. So in add transition, we want to create something, a transition of type state transition. And we want to, so a little trick here, since it's trying to do autocomplete, I'm going to hit escape. I'm going to say state transition escape so it doesn't try and autocomplete. And we're going to go from to condition All right, and then we are going to say state transitions dot add transition. So we're going to add that transition to a collection of transitions. We're going to create that type, create type, and that all looks good. And I am going to create in here an I state. I'm going to make this a public read-only I state from public read-only I state to, and then a public read-only func bool condition. And then in our constructor, this is a class constructor, we are going to say to, well, from equals from, to equals to, and condition equals condition. And that's pretty much all we need there. We're going to move this into its own file. Nice. All right, so now we want to create this collection. Control period, create field, state transitions. And this is going to be a list of state transitions. And now we need to import system collections. Actually, I think we just want, do we want generic? I think we do. All right. So now we have that collection. I want to initialize it. So now this should compile, but if we go back and run our unit test, it still should not pass. Let me open up our unit test, make sure we're on edit mode, run that. And it does not. So we're still in the red state. Okay, so in our state machine, what do we do in tick? Well, what we want to do is we want to check for our transition. So we're going to say transition equals check for transition. And if that's not null, then we want to call set state transition to. And then we want to do tick on the current state. So there's a few things that don't exist here. Check for transition. So control period, create method. And this will be a state transition. Check for transition. So what check for transition is going to do, we're just going to return state transitions first or default, and we're going to do a little lambda here. We basically want to see if the from is the current state and the condition is met. So it will find the first item in our collection of state transitions where we're transitioning from the current state, and the condition to make the transition is true. Okay, and then tick, I'm just going to hit create that method, and that creates it on the interface. So we'll just leave that for now and go back into our test, and let's run this test. Test not run. Let me try that again. And it passed. So the reason it passed is because we had a transition that went from the first state to the second state, and the condition should transition state was true. So when we did tick, it checked for a transition, found that transition and that it was true and ready to go, and then it returned the new state, the transition 2, which is second state, and set our state to that. Good. But that still isn't all the functionality we need from our state machine. So we're going to want to add another test. We do not want to make the transition if the condition is not met. So let's try that. Public void transition does not switch state when condition is not met. Okay, so we're going to copy a bunch of stuff here. I'm just going to go ahead and copy all this, and then we're just going to change it as needed. Okay, so we have our first state, our second state. We're going to set this to false. And then we just want to make sure that we are still, oops. We want to make sure we're still on the first state. So basically, we have a transition to go from first to second, but if the condition isn't met, we should not change state. Let's go ahead and do a Control-Shift-B to build. All right, open up our unit tests. And I'm actually just going to right-click here and say Run Unit Tests. And we got our new test here, and it passed. So we didn't need to add any new logic for that. Well, how about if we're not in the correct source state? That would be a good one to test. Where is our ending bracket? Right there, okay. So let's add another test. Public void transition does not switch state when not in correct source state. Oop. I'm going to again copy all this. I'm going to add a third state. So we set the state to the first state. We'll go ahead and set this to be true. So we have a transition to go from, let's make it from second state to third state. So our transition goes from second to third if the condition is true, but we're currently in first state. So we would expect that we would still be on first state and that it did not change to the third state. Run unit test. There's a new test. Good. Now we do want to have the ability to go from any state to another state if a condition is met. So let's write a test for that, and this one should initially fail because we have not implemented the logic for this yet. So I'll say public void transition from any switches state when condition is met. So let me copy all of this again, and we'll just modify it as needed. We're not going to need third state anymore. Our transition now, we're going to add an any transition, and we're only going to set a to state and then the condition. And let's see, I think that this should change to the second state. So let's go ahead and hit Control period, create, add any transition method. I will delete this. All right, so we want to go to func type bool condition. All right, so we are going to do basically what we did, I want to move this up a little bit here. Yeah, we're going to do pretty much what we did for add transition, except we're going to have a different collection, and there's not going to be any from. We're still going to use the same state transition object. It's just we're going to have null for from, then we're going to have to, and we're going to have condition. And then we're going to have any state transitions transition. And I'm just going to come up here and I'm going to copy this and paste. And this will be any state transitions. And we'll make these read only. Only updated, never used. Okay, cool. Now, our test still won't pass, and I can go prove that to you. We'll build, go into our unit test, and we will run this test. And it failed. And the reason it failed is because we're not handling the any state transition. So when we check for transition, what we're going to do here is say var transition equals any state transitions, first or default, and all we're going to check is the condition. And then here we're going to return transition, or if that's null, we'll check the other regular transitions. Now let's go back into our state machine test, open up our unit test, and let's rerun this failed test. Maybe I should have done a build first. Let me try that. Control-Shift-B to build. All right. And then run that test. I'm wondering if it's not stuck in an infinite loop somewhere. Let's jump back into Unity and try and run it from here. And it ran. Yeah, sometimes running them from the editor is weird. And see how fast all these tests ran compared to the play mode test? So you can see why, if you can write a lot more edit mode tests and they'll complete much faster than the play mode test. So as much as you can, try and use edit mode tests. Now we want to also expand our state a little bit. Right now there's pretty much nothing in here. There's a tick method on the interface that pretty much does nothing. But let's add some more tests. We want to, when we transition from one state to another, we basically want an onEnter, an onExit method to be called. And we also want to, every frame, have a tick method be called. So each state can do something every frame. So the parent mono behavior that owns that state machine will tell the state machine to tick. The state machine will in turn tell the current state to tick. And of course, we're already doing the check for transitions as we've seen here. So in our check for transition, we return the current transition. And then whether we change state or not, we're going to call tick on that, whatever the current state is. So we have the tick method, but we want to also have an onEnter and an onExit. So when we set state, in addition to actually setting the current state, we want to fire an onEnter on the new state. We want to fire an onExit on the old state. And we're also going to want to have an event on the state machine itself that says that the state changed. But we'll get to that. The first thing I want to handle is the onEnter and onExit and tick methods of our state. So the first test I'll write here And this is just going to be a simple test to make sure that when we set the state, on enter gets called one time. So we're going to say public void state on enter called when setting state. All right. So this is going to be very simple. We'll create a state machine. We will instantiate or substitute a state. We'll call it first state. And then we're going to tell our state machine to set the state to first state. And then this is like doing an assert, but this is basically going to take advantage of something on the inSubstitute class. We're going to say first state received one call of on enter. Okay, and so this will basically succeed the test if on enter was called one time. Otherwise, it's going to fail the test. All right, so let's go ahead and create this on our interface. Right, so there's now a void on enter method on the interface iState. So let's go ahead and build. And that built. So let's expand our unit test here, and we are going to run that test. Said inconclusive run was canceled. Why was it canceled? Looks like another case where I'm going to have to jump out into the Unity editor and run it from out here. So let's select that, run selected, and it failed. So this failed. Can you guess why it failed? I'll give you a hint. Red, green, refactor. So red, you initially write the test, and it's going to fail because you have not yet implemented the code that needs to make it pass. So what we want to do is in our set state function, all we're doing right now is setting the current state. And we can actually short circuit this, by the way. I want to say if the current state is already equal to, and I'm going to rename this to be new state. So if it's already equal to new state, let's just return and not do anything. All right, so we're setting the state to be new state. How about we say current state on enter? So if we have a new state, because it is possible you would set the state to null. So if we set the state to null, we don't want to try and call on enter. So let's now go back to our state machine tests, Control-Shift-B to build. I'm going to tell it to run all these tests and just see if they run. They all ran, and now that test passed. So good. We now know that when we change state, on enter is going to be called on the new state one time. Good. What other test do we want? How about we test that on enter, on exit, and tick get called when transitioning from one state to another. So we'll come in here and we will say public void state methods called when transitioning. All right. So let's say var state machine equals new state machine. We're going to substitute a first state. I'm going to copy that and make a second state. And we're going to set our condition should transition state to be true. We're going to add a transition. It's going to be an add any transition. So we're just going to transition to the second state. All right. And we're going to start out on the first state. And then we're going to tick. So now it should have transitioned to the second state. So all we're going to do is check to see if these methods were called. So we're going to say first state received one call to on enter. And that would have been when we set the state here. And we're also going to check to see if his onExit was called. Hey, that doesn't exist yet. So we're going to create that. Now we want to see if the second state received an onEnter. We want received, not returns. And they should also receive a tick. Actually, it would just be tick. Yeah. All right, so let's go ahead and create this on our interface. So now we've got tick, onEnter, and onExit. Come up here, do a Control-Shift-B to build, and run all. And they all pass. Which surprises me because I don't remember adding the call to onExit from here. Did that? Oh, that function isn't there. Yeah, okay, that definitely failed. So it expected a call to onExit. It never got one. So again, we need to go into our state machine. And where we're setting the state, before we change the state, we want to take the current state and say onExit. Now let's go back, Control-Shift-B to build, and rerun this test. And it passes. All right. The last thing I think I want to do here with our state machine is I want to confirm that the onState changed event is fired when we change states. Or I guess even if we just set the state would be good enough. So let's add a test here. Public void state machine onState changed event fired when setting state. All right. So what we're going to do here, let's just go ahead and copy these. And then we're going to say state machine.set state first state. And what I'm going to do here is I'm going to say state machine on state changed plus equals, and I want to handle an event the same way that we did in the other class, if you remember. This is actually going to take a state, and I want to say assert our same first state expected event with first state. All right, and then down here I will say assert fail. So let's come in here, create event on state changed. I am going to move that to the top of the file, to the very top. And this will be an iState. And then when we set the state, the very last thing we're going to do is say on state changed, invoke current state. So I'm thinking I want this here. We will see. Let me just do a build and then we'll run that and see what happens. Let me right click on this, run unit test. And this may be another one where we need to go back into the Unity editor and run that from in here. Let's go to the error line. Yeah, so I don't think we want this. Here's how I'm going to handle it. I'm going to add a variable here, iState expected state. I'm going to set that to null. And then in here, I'm just going to cut this. And I'm going to say actual or expected No, I want this to be actual here. Actual state. So in here, I'm going to say actual state equals state. And then down here, my assertion will be that this actual state is now equal to first state. So let me build. And then we will try and run this again. Well, I wanted this one. What if I just run them all? It just doesn't like it. Let's jump back out in the editor, the Unity editor that is, and run them all. And there it goes. Okay. So now we are firing an on-state changed event when we change states, and all of these state machine tests are passing. Well, I think I'm going to call that a wrap for this video. We got some good progress in there, wrote some new unit tests, did some test-driven development, and began scaffolding out our state machines. So if you found that useful, do me a favor and click that like and subscribe button. It really does help me to grow my channel, and I want to get this content in front of as many people as possible. And be sure to tune into the next video where we'll start putting those state machines to good use and get them controlling the enemy landers and the humans. And we'll even see if we can't design the level out a little bit more and get it to look more like a playable level of Defender. And if you have any questions or suggestions, drop a comment below and I'll get back to you as soon as I can. And if you have any detailed questions or problems, post to my Discord channel. I'll put a link in the description and I can get back to you with a little bit more detailed response than we could do on a YouTube comment. So thanks so much for watching and good luck on your game development journey.